Hi, I'm Carl Lawrence with FTS Hydrology, and today I'm going to give you a quick introduction to DigiTemp, our new digital SDI-12 submersible temperature sensor. DigiTemp is primarily for measuring water temperature, but it can also be used for soil or other liquids. It's fully digital and works with any SDI-12 compliant data logger. It's also been approved by the HIF, so for all you with the USGS, you can also stock it. What's really great about DigiTemp is it requires no complex wiring and there's no need to program coefficients. You just plug it in and you're basically done. So it makes adding temperature monitoring to your station incredibly simple. So I'm going to demonstrate the differences between DigiTemp and an analog temperature sensor and show you how simple it is to install a DigiTemp. As you can see, this is the DigiTemp. It's got a very distinctive appearance. The sensor itself is a highly accurate thermistor coupled to an SDI-12 circuit board that will output temperature in degrees Fahrenheit and Celsius with a simple on command. The housing is made from Delrin, which is a really rugged engineered resin. It's strong, stiff, and provides low friction. This end loop makes it easy to fish it through standard PVC pipe, and it was designed to fit down an 8-inch factory bend on 1-inch PVC pipe. This end loop also makes it handy for anchoring in fast-moving water. The strain relief here also helps to protect the cable. DigiTemp comes with a standard 60-foot cable. This is the same cable that we use on our DTS-12 turbidity sensor, and it's a really premium cable. It's extremely durable, it's UV resistant, and it has an internal water block. If you cut into it, you'll notice that it has a really sticky, gooey substance. That's the water block. So it will survive nicks and even deep gouges and cuts. Cable end is just 3 flying leads, and one for power, one for data, and one for ground. If you have an Axiom data logger, then you'll want to order your DigiTemp with the watertight bayonet connector, as you can see here. So let's compare DigiTemp to a typical analog temperature sensor. I've got one here to show what it's like to install using an FTS Axiom data logger. But remember, it's compatible with any existing data logger that has an SDI-12 port. Okay, so now let's see what it's like to hook up a DigiTemp. We will either have 3 flying leads that hook up to a SDI-12 port, or in the case of the Axiom, we have this very nice bayonet connector that we just snap on. And we go in and we detect the sensor. Okay, so now that we finished detecting, you can see that the DigiTemp has now appeared as a new sensor. We click on the new, and you can see that it's on address 1 and it is an active sensor. We now want to go in and set the command for it. It automatically comes up with an M command, and that's exactly what we want. We'll now add in the fields. The first field we want is going to be, we'll give it a variable name. We'll call it temp C. So this is our Celsius, and then we want another new field for the temperature in Fahrenheit, and we'll call it a temp in Fahrenheit, and it's in field number 2. We now have set up the whole sensor. We have it now showing as an M command, and there we have it. We have temperature in C for 24 degrees, and we have temperature in Fahrenheit at 75.7. Now I'm going to wire in the analog sensor. As you know, when you go out into the field with a 2-wire analog temperature sensor, you do need to remember which resistor to bring. So in this case, this one that we'll be doing has a built-in 20 k ohm resistor, but lots of them you need a 10 k ohm resistor to do the biasing between the 2 analog ports. So don't forget your resistor if you have an analog temperature sensor. I'll actually be wiring in this analog module, which is how the Axiom connects to analog sensors. This is just connected to one of the Axiom's 4 SDI-12 ports. It has a series of terminal strip connectors, so basically allows us to simulate another data logger. The integrated touchscreen on the Axiom eliminates the need to connect a laptop when programming. So with this one here, as with most, we're going to wire it in to 2 analog ports, and we're going to use this SDI-AM to do that, and we're also going to use the excitation port here. So I'll wire up the excitation first with its little jumper and put that on there, and then we'll use analog port number 2. We're going to use the ground on that one. We're going to hook up the reference to that, and then we're going to hook this one right up to there. So that's the wiring. If we had a biasing resistor, instead of using this red wire, we would actually be hooking the resistor between here and this port here. That's how we would do a 2-wire temperature sensor. So the wiring's not overly complicated, but you do have to know this. The next section is to go into a data logger, and every data logger is different. Within the Axiom data logger, we have the ability to talk through SDI-12 to this, so it's going to be a little bit easier, but I still have to go through and configure all of these 3 ports, the excitation, analog 1 and analog 2. I have to enable them to be able to power this correctly and read the correct values from it. The first thing I'm going to do is I'm going to go in and enable these 3 ports on analog 1, and I'm going to edit it. And I'm going to come in here and I'm going to give it a name, and in this case I've called it VREF. So this is going to be my voltage for reference. So this will be the 5-volt reference voltage that I'm going to use. And then I would come in here and I have a choice here on ours as to how I'm going to do it, whether it's current looped or single-ended. And in this case we're going to do single-ended, and off of the list that we have here we're going to choose 0 to 5 volts. We then move over to the second analog port, and we basically repeat the process. And in this case, this is going to be our VTemp. These are just variable names. We can call them whatever we like. We then move over to the excitation port. And the excitation port means that we want to power the unit slightly before the reading is taken. So we want a 2-second warm-up, so we would type in here and up this to 2 seconds. This is also where we put in our reference voltage as well. Once we've set all these, we would then choose the interval that we want it to read, and in this case it's set up to read once every minute. It will now give us these outputs. So you can see we have a reference voltage, very rock solid voltage of close to 5 volts. And we also have now the millivolt reading that is across the resistor that is the temperature, is the thermistor. In this case now, we now need to go in and create some processes that will convert this voltage into ohms. I would have to create at least 3 processes. I could do it with 2, but 3 will make it a little easier to see what's going on. So the first one I'm going to do is called, I'm going to give it a new function name, and I'm going to call it rtherm. And rtherm is going to take VTemp and VReference and convert them from the millivolts that were produced across the resistor into ohms. So they're going to do an ohms reading. And it happens that this analog sensor that I'm using, the reference precision resistor in it is a 20 k ohm resistor. So now that we've converted the millivolts of the analog temperature sensor into ohms, now the next thing we have to do is convert that ohms into temperature in C. To set that up, we're going to have to use the Steinhart-Hart equation. So with the Steinhart-Hart equation, I don't know it well enough, and I'm sure most of you who are watching this don't know it off by heart. We'll be using the 3-variable Steinhart-Hart equation. Now, our data logger allows us to do a bit of a cheat sheet, and we can type in a pretty easy function to create the Steinhart-Hart. But for the rest of you, you're going to have to type out this very nice equation with these 3 variables. So there you go. It's incredibly easy to install. DigiTemp doesn't require any calibration or maintenance once it's deployed. It will remain active for years. It can be used in salt water as well. Fast-moving water is no problem. You can deploy it inside a PVC pipe or anchor it. The maximum weight you can use, though, on the end of the eye here is 10 pounds. And of course, it fits easily through a standard 1-inch PVC pipe with 8-inch factory bend in it. The sensor comes with a 60-foot cable, but extra cable is available from us by the foot. The sensor will work reliably with up to 500 feet of cable. You can either splice it on yourself or even have us splice it on for you with the water-resistant splice. If you want to splice on your own cable, just make sure it's 20 gauge or heavier. And if you want to make the cable shorter, you just remove a couple of inches of the outer jacket to expose the leads. And remember, there is that gooey water block on there. It doesn't come off easily, but off your hands or tools, but you can use a product like Goo Gone, and it works great to be able to get it off thoroughly. Thanks for watching this video. We hope you've learned how easy we've made it to add temperature monitoring to your stations. If you need any further information, please give us a call or visit our website. I believe the phone number and URL will be appearing on the screen right about now, from somewhere anyways. It can be added onto any existing SDI-12 compatible data logger, and it's easy as plugging it in and walking away. The sensor is available via the HIF, and that's for all you USGS guys, give them a call, or directly from us at FTS, and there are pretty significant quantity discounts. You can actually get a quote directly from FTS Hydrology website as well. Thank you again on behalf of FTS Hydrology. I'm Carl Rennes. Bye for now.